This video is for Chapter 3, Section 1 about parallel lines and transversals. It is intended to be viewed before the assignment on this section. First thing we're going to take a look at is this picture here, in which there are two lines, line M and N, which are not parallel. Eventually these lines will intersect, but currently in the picture we're looking at, they are not intersecting in this section. And we have line K. The first thing we're going to define is the word transversal. Line K is a transversal. It is intersecting two or more lines. So we will not call something a transversal unless we can see the lines that it is intersecting. We might say line K is transversal to line M and N. A transversal line is one that intersects two or more lines. Now, once we have a transversal intersecting these two lines, 8 different angles are created. Some of the angles we know. 1 and 2 are adjacent, 1 and 3 are vertical angles. But what we want to start looking at is what are the relationships to the first 4 that are created with K and M, and the second 4 that are created with N and K. The first relationship we're going to take a look at, angle 1 and angle 5. These will be defined as corresponding angles. They have a corresponding or similar location, not similar, but the exact same location. Upper left corner of the intersection, upper left corner of the intersection. These are corresponding angles. Whether or not line M and N are parallel, if you have a transversal to two lines, you have a pair of corresponding angles. In this case, corresponding has nothing to do with what their measure or size is, but rather just their location. 2 and 6, corresponding. 3 and 7, corresponding. 4 and 8, corresponding. Okay, the next relationship is angles 3 and 5. Angles 3 and 5 would be called alternate interior angles. They are between the two lines and on alternating sides of the transversal. Okay, we have alternate, which here is the transversal, and angles 3 and 5 switch sides. 3 is on the right, 5 is on the left of line K. That's the alternating portion. The interior word is because the two lines that we're looking at, if we were to squash them together, 3 and 5 are both in between the two lines. So they are alternate sides in between the two lines. Alternate interior angles. There is one other pair of alternate interior angles currently, and those would be angles 4 and 6. Our third relationship that we're going to look at are angles 4 and 5, which we will call same side interior angles. They are on the same side of the transversal, both on the left here, and they are interior as we defined earlier, being between M and N. So same side interior angles. The other example of same side interior angles are angles 3 and 6. A big part of this unit, and especially this section, is just being able to identify what types of angles we're referring to. So here we have the examples of them. There are some other names that we may decide to add to this list. 2 and 8. We may decide to say that, well, now that we have these definitions, they are on alternate sides, but they are on the exterior of the two lines. So we may call those alternate exterior angles in discussion. 2 and 7 could be referred to as same side interior angles. But a majority of our work will be based around these 3 definitions. Now, the only change between the previous slide and this slide is now we are looking at M and N as actual parallel lines. Nothing has really changed. One and 5 are still corresponding. 2 and 6 are corresponding. 3 and 5, alternate interior. 4 and 5, same side interior. Nothing has changed, except for a moment we want to take a look and visually think, is there or are there relationships developing about these angles? For example, if we truly believe that M and N go in the exact same direction, and you take a straight line and cut through them, it should form an angle with M, and therefore since K is not changing directions, it should form the exact same angle with N. We should be able to believe this. M and N go in the same direction, being cut by a line going in one direction. They will create the exact same angle. So 1 and 5 are currently corresponding, and because the lines are parallel, they have become congruent. This leads us to the first of our three major postulates and theorems about this section. Now M and N is parallel, so this is a condition. We studied conditionals. If M and N are parallel, if two parallel lines are cut by a transversal, so they have to be parallel, here is a result. Corresponding angles are congruent. Remember, the lines must be parallel, and there's actually a second condition here. They must be corresponding angles. So if we have corresponding angles and we have parallel lines, we can make the conclusion that they are congruent. Okay, so I put in here again so we can write down. We must establish that they are corresponding angles. We have to say that, and we have to notice that they are parallel before we make them congruent. Now, we're going to use that information to actually prove something. We know that angle 2 is congruent to angle 3 because they're corresponding. The question is, does that mean that angle 2 is going to be congruent to angle 1? So we start off with, and this is based on the proof work we've done the last 2 days, line M and N are parallel, and I would like to prove angle 1 is congruent to angle 2. Well, here are some statements that I can say. I know that M is parallel to N. I know that 2 and 3 are corresponding. So because of these two steps, parallel lines, corresponding angles become congruent. And then I start a whole nother thing. 1 and 3 are vertical. That's the relationship between 1 and 3. It has nothing to do with this. And that means 1 and 3 are congruent because we know that if two angles are vertical, then they are congruent. Well then, angle 1 must be congruent to angle 2. Here are our reasons. This was given to us. We had to have a place to start. We also know that they're corresponding because they meet the definition. We see that they are in the same location of the transversal. Well, parallel lines, corresponding angles, therefore they are congruent. That was the corresponding angles postulate from the previous slide. Now we start over. How do we know 1 and 3 are vertical angles? I look at the picture, I see that they are across from each other. They meet the definition of vertical angles. Now they are vertical angles, so if they are vertical angles, then they are congruent. That is the vertical angle theorem. If they are vertical angles, then they are congruent. Now if we put all these things together, what I'm only going to look at is statement 3, 5, and then 6. If 2 is congruent to 3 and 1 is congruent to 3, then 1 is congruent to 2. This is one of the properties of algebra, the transitive property. What we've done here is we have allowed ourselves to say, given this picture with parallel lines, we know 2 and 3 are congruent, we know 1 and 3 are congruent, so therefore 1 and 2 are congruent. We have proven that alternate interior angles are congruent only when the lines are parallel. So, we have now proven that if two parallel lines are cut by a transversal, then alternate interior angles are congruent. This is called the alternate interior angle theorem. Corresponding angles postulate said the corresponding angles are congruent. Now we know that alternate interior angles are congruent only when the lines are parallel. The third and final one for today is to understand the same side interior angles. Now we're not going to put up the proof, rather we will actually do that in class. So right now we're just going to go with what the final theorem is. So the third one is that the same side interior angle theorem says same side interior angles are supplementary, only if lines are parallel. So we'll start with the lines being parallel. We know that angle 1 and angle 5 are congruent because they are corresponding. And we know that angle 1 and angle 4 must add up to 180 degrees because they form a straight line. Now, if angle 1 and angle 4 add up to 180, and angle 5 can be replaced with angle 1 because they're congruent, then we could say that angle 4 and angle 5 add up to 180. And adding up to 180 degrees is defined as two angles that are supplementary. So angle 4 and 5 add up to 180 degrees, and we make the conclusion that means they are supplementary. So anytime we have parallel lines, same side interior angles must be supplementary. We move forward to say that that means they add up to 180, and we can use this to solve problems. So that wraps up the material, the new ideas of vocabulary and theorems and postulates for this section. What we want to do now is take a look at a few examples of how we're going to use this material as we come into class. Okay, here we have a couple of examples for the material we were just looking at. In my first picture, I have four lines, line J and K, which are marked parallel to each other, and line M and N, which are not parallel to each other. Or at least we're not told that they are parallel to each other, so we must assume that they're not. We have a couple questions here. For example, what is the relationship between these following angles, and are they congruent or not? So the first one we have is angle 1 and 4. Now 1 and 4 are in the same intersection. They don't even have to worry about the parallel lines or not parallel lines. This relationship is they are vertical. So, vertical angles. Does this mean that they are congruent? Yes, because the vertical angle theorem says that if two angles are vertical angles, then they are congruent. Next relationship, 2 and 6, if we had to name that. 2 and 6, well, upper right corner, they're in the same location, corresponding angles. Okay, corresponding angles, we'll use an abbreviation. Question, are they congruent? Well, 2 and 6, the transversal is J. The lines creating them are M and N. These two lines are not parallel, therefore they are not congruent. Okay. Now we have 2 and 9. 2 and 9. Okay, well, the transversal, we got to identify the transversal. What line are they both touching? M. M is the transversal. 2 and 9 are in between J and K. So that actually makes them interior angles. And they are on the same side of M. A lot of students mistake these for being exterior angles because we see them being up top. But they are between J and K, and they are on the same side of the transversal M. This makes them same side interior angles. And we're asked, are they congruent? Well, no. They are supplementary. Because the same side interior angle theorem tells us that same side interior angles are supplementary when the lines are parallel. And we have two lines, J and K, that are parallel. Finally, we have angle 6 and angle 15. Again, N is the transversal, but J and K are the lines that they're touching. They are parallel to each other. N represents transversal, cutting parallel lines. So this is going to be alternate sides of N on the interior of J and K. This is my example of alternate interior angles. And in this case, they are congruent because of the alternate interior angle theorem. We have parallel lines that allow us to make these congruent. So this is what we do here. If I wanted to say, yes, these are supplementary, I could say that this is the same side interior angle theorem as well. And at least I have a justification for why these angles are same side interior. Now there's a bunch of other angles in here. We could look at things like 4 and 12 corresponding. Are they congruent? Yes, because they're corresponding off of the parallel lines. But 12 and 16 are also corresponding, but not congruent. 14 and 16, we could just call those adjacent. Not congruent, but adjacent. 16 and 10, let's call those alternate exterior. Are they congruent? No. Are they supplementary? No, they're not being made by the parallel lines. 8 and 15, same side interior angles. Supplementary, based off parallel lines. 3 and 6, alternate interior, but not congruent, because they're not based off the parallel lines. Finally, a second example would be this problem here where we're solving for x and y. The parallel lines are along the top and the bottom. If we actually extend the parallel lines and the transversal, we begin to see that the transversal is here, which means these two angles, 6x and 3x, are same side interior in between parallel lines. Therefore, 3x and the 6x are supplementary. So we can say 3x plus 6x is equal to 180. 9x is equal to 180 when we combine the like terms. We divide by 9 and we end up with x is equal to 20. Now we don't want to make the mistake of saying 3x plus 5y is equal to 180 because they are not touching parallel lines. Parallel, not parallel. So 5y and 4y plus 22 is what we must look at. Extend the lines, and we see these as alternate interior. Now, these alternate interior angles touching the parallel lines mean that they are congruent. We can say that 5y is equal to 4y plus 22. They are congruent angles. Subtract the 4y from both sides and we have our answer, y is equal to 22. Those are two brief examples and ideas for what you're going to be dealing with on the assignment involving Chapter 3, Section 1.